All right. Hi everyone. We are live again. Welcome back to this amazing platform of QT Learning. And today we are going to discuss the paper 2. Right. So welcome back to this amazing platform of QT Learning. Right. I hope you are doing good. Right. And so I also covered the previous solutions of paper 1 in my previous videos. If you haven't watched those solutions, I would request all of you to please go back in the under the live tab. You can find up all the solutions that I have discussed for paper 1 as well. Right. So today I'm going to do the same thing but for paper 2. Okay. And we're going to again start with the math solutions over here, and we're also going to discuss that how can you how would you have solved these questions for the different approaches as well, right? And this sessions is going to be very useful even for the class 11th and class 12 based students, those who are basically going to appear for JEE mains and JEE advanced in the coming year. Okay, so all the solutions that I'm going to discuss are basically going to help you out in preparing for the upcoming exam as well. Okay, so keeping those things in mind, let's get started. Right, so our only goal today is basically to discuss the JEE Advanced 2025 paper 2 solutions. Okay, so in the last videos I have discussed the paper 1. If you haven't watched them, you please go to the channel, and under the live tab you can find up all those questions as well. Right, so let's get started with this part. Okay, so here we go with the very first question, and it's a single correct based question that came up in the JEE Advanced 2025 paper. Okay, so let's try to see how we go about solving these questions. Right, so let's try to first of all read the question and try to understand what the questioner is trying to convey. Right, so it is said that let x naught be the real number such that e to the power x naught plus x naught is equals to 0. Now, it's also said that for a given real number alpha, define g of x as 3x e to the power x plus 3x minus alpha e to the power x minus alpha x divided by 3 times of e to the power x plus 1. Right. So we have a bigger function over here, and said that x naught is a real number such that we will have the solution for x naught plus e to the power x naught plus x naught is equals to 0. Right. So x naught is the solution of this particular equation, and then for a given real number alpha, it is said that this particular equation g of x, or this particular function g of x, is defined as follows, right? So looking at the problem, it is said that, right, and 3 into e to the power x plus 1, right? That's what is mentioned as function g of x. Now looking at the following function, it is said that you have to choose which of the following statements is or are correct, right? So you have to choose for the correct statement. For different values of alpha, you have to figure out that which of the following limit is or are correct, right? So that's a simple problem over here. Let's try to see how we go about solving this problem. So if we look at the g of x function, let us try to analyze the g of x function first of all. So if we look at the g of x function, what I can do is that if I take 3x as common, then and I divide it by the denominator over there, then I will get it as x minus alpha times of e to the power x plus x divided by 3 times of e to the power x plus of 1, right? So this will be our g of x function. Now it is said that g of x, then g of x plus e to the power x naught will be equal to x plus e to the power x naught minus alpha times x plus e to the power x whole divided by 3 times of e to the power x plus of 1, right? Then it is also said that after you have this particular form over here, then it is said that g of x, right, it is basically g of x can also be written as, so if I have this particular form over here, then and if I combine this e to the power x naught with this form, and then if I write it, so g of x plus, so I can be able to write g of x plus e to the power x naught as equals to x minus x naught minus alpha upon 3 into e to the power x plus of x whole divided by e to the power x plus of 1. That is what I can define over here, right? Now as we are very clear, as we know that g of as we know, g of x naught plus e to the power x naught, right? So e to the power x naught, that is what we have to find over here is a numerator, right? Yes, correct. So we have to basically look at the options. If you look at the option, the numerator is common, that is g of x plus e to the power x naught, right? So all of the numerator we have g of x plus e to the power x naught, which is basically this particular function over here, right? Now you have to figure out that for different values of alpha, right? So if I use the value of alpha as, so over here, if I put the limit, so if I put the limit x tending towards x naught, if I put the limit x tending towards x naught, and then g of x plus e to the power x naught whole divided by x minus x naught whole divided by x minus x naught, and then we put a mod over here, what we see that if we look at this following form over here as x tending toward x naught, this particular form will be equal to 0, right? And similarly this form, since e to the power x naught plus x naught is also equal to 0, so this will also go to 0. So we will have a 0 by 0 form over here, right? So we will have a 0 by 0 form over here, right? Therefore I can simply use the L'Hopital rule, and I can differentiate both the numerator and the denominator for x naught, and that will give me g dash of x, and x naught is basically a constant, right? E to the power x naught is a constant because your x is variable, not x naught, right? So it will be g dash of x divided by 1 and mod of that. Now if I put, the limiting value will be equal to g dash of x naught. Now the limiting value will be equal to g dash of x naught, and we have to put a mod over here, right? Therefore from this particular result, then we can calculate g dash of x as simply as 1 minus alpha upon 3 multiplied with e to the power x plus of 1 multiplied with e to the power x plus 1 and minus e to the power x plus of x into multiplied with e to the power x, and then whole divided by e to the power x plus 1 and whole square of it, right? Just use the quotient rule for differentiation over here. Now once we have this, if I put g dash of x naught, so g dash of x naught will be equal to 1 minus alpha upon 3 whole multiplied with e to the power x naught plus of 1 and whole square of it, because this thing is going to be equal to 0. As we put x naught, this is going to be 0, right? So that is whole square of it divided by e to the power x naught plus of 1 and whole square of it, right? Therefore this part is this part going to cancel out, and we are going to have the answer as 1 minus alpha upon 3. Now we're going to check that if alpha is equal to 3, the value of this limit, this value of g dash of x naught is going to be equal to 0. And if we have alpha equal to 2, then the value of this g dash of x naught is going to be equal to 1 upon 3. So if you look at the options over here, if you put alpha is equal to 3, if we put alpha is equal to 3, then only this particular option number C is going to be the correct answer. So therefore it's a very simple problem. So the answer to this particular problem is going to be option number C. Very simple. I think that every one of you must have solved this problem, right? It's a very simple problem. Just if you look at the just you go on doing the steps, then this is going to be very, very simple. All right. So I hope this part helped you a lot, right? So I'm hoping that the solution is clear to all of you, right? Please let me know if the solution is clear or not. Please do let me know if the solution is clear or not, right? It's a very straightforward problem. If you go on solving the problem in the way it was given, and if you look at the options and the question that was asked, that is g of x plus e to the power x naught, if you try to find out and then divide by x minus x naught thing, then you are going to get the solution is a very simple manner. Okay, so that was what is asked in the problem over here, which you can think that you can solve it easily. Okay, so I hope this is not an issue for any one of you. It's a very simple, straightforward problem. Okay, so it's a, I think every one of you should have finished this problem. Okay, any more questions? Any questions on any of you? If you have any questions in this problem or the solution, please let me know in the live chat. Please let me know in the live chat. Is there any problem? Is this clear for all of you? Right? And are you all getting option number C as the correct answer? Please let me know. Are you all getting option number C as the correct answer or not? Right? So if you have solved this problem patiently, then this question won't be a difficult difficult to anyone. Okay, and if you look at the paper 2 was little bit easier. Okay, little bit easier as well. Okay, right. So I hope the solution is clear. Let's move to the next problem. Let's go to the next problem from here. Right. Yeah. So the next problem is a problem from area under the curve, and it's a very interesting problem if you look at the problem statement over here, right? So if you look, and this kinds of problem has been asked many times in mains, in advanced, and in previous year problems as well. So it's not an interesting problem in terms of that, but it's a very simple problem, right? Let's try to see how we go about solving this problem, right? Again, very simple problem. Just try to figure out the graph, just try to figure out the region which is basically been asked, and from the region, if you try to use your if you without even doing the integration as well, we can get the result as well, right? So if you just use some of the tricks, then we can also get the result directly. Okay, so let's see how we can do that. First of all, let us try to first of all figure out the region that is basically given over here. So I'm using this particular space to plot the region. Okay, so first and foremost thing, it is said that x and y belongs to the real number and x is greater than 0. So all our analysis is going to be in the positive side of x-axis, right? That's great. Now it says that y is greater than 1 upon x. So if we look at y is equal to 1 upon x, it is basically a rectangular hyperbola. Okay, so this will look like this way. So the rectangular hyperbola actually looks like this, right? Then if you look at the next inequality, it is said that 5x minus 4y minus 1 is greater than 0, which is nothing but it is this following equation. Okay, it is a straight line, and the straight line will be like, so if I put x equal to 0, your y will be equal to minus of 1 by 4, and if I put y is equal to 0, your x will be 1 upon 5. So it is like a straight line passing like this. Okay, it's like a straight line passing like this. And if you look at this particular straight line over here, it's a straight line which is basically having the intercept as 17 upon 4 and 17 upon 4 in both the x and y axis as well. So it is this particular like this over here, right? Please don't mind my figure a little bit. Okay, I am trying my best. Yes, so kind of like this. Yes, okay. So it's a very simple thing over here. Now, if you look at the region that is basically asked over here, if you look at this for the first equation, the region that is basically said is basically this particular region, right? Is particular this particular region. And then if you look at for this particular line for this first equation, or maybe I can call the second condition, this as a first condition and this one as a third condition, right? So the second condition, if you look at the inequality, it is basically talking about this particular region, right? And the third inequality is talking about this particular region. Okay, now I will use an arrow to indicate which I'm trying to refer to, right? As well as if you look over here, we actually need to find the following area as follows. So we actually need to find the area of this. The required area is basically we need to find the area of this particular region, right? So the common region that we have over here with us is basically this particular region. So if I try to name something, then it will be easy. Let's call this A. Let's call this perpendicular drop as B. Let's call this one as C. Let's call this one as D, and let's call this one as E, and let's call this particular point of intersection as P. Now if you find out the intersection of line 2 and line 3, the point P will come out as 2 comma 9 upon 4, 2 comma 9 upon 4, right? So we will have the following point P as 2 comma 9 upon 4, right? It's very simple. You can just simply solve this inequality and the equality and this equality to get the direct point, right? So if you look at the region is basically, so I will use a different color maybe. Okay, let us use a red color. The region is this one plus and so we will also have this particular region, right? This particular region over here. Yes, right? So this is a common region, we need to find it out. Now, if you are smart enough to understand this, how will you find the area? So directly you can find the area as the, first of all, if you find the area of the trapezium, area of this trapezium, okay, first of all, let us find the area of the trapezium AP, APBC, and then add the area of the trapezium, and then add the area of the trapezium PDCE, right? PDCE, right? So that will actually, so if you look at over here, the yes, so that will actually give you the required area, right? So if you try to find out the area of the trapezium APBC, so that is basically half into the sum of the base of the side into 1 plus 9 upon 4, 1 plus 9 upon 4, and then we'll have yes, so that is going to be like yes, 1 upon 9, 1 plus 9 upon 4, then we will add plus 1/4. This will be like 9 upon, and the distance between the parallel side is basically 1, right? And this is going to be like 1 by 4, because here the distance between the parallel side is half, 9 by 4 plus 1 by 4, right? And multiplied with, because we need to subtract, then we need to subtract this particular area, that is this region. Okay, so I will be using a yellow colored or maybe a black direct violet color. So this region we have to subtract as well, right? This region we have to subtract as well. So that is the, so that region we can subtract as, it is basically uh, we can write it as, so this particular region what we need to subtract is basically integration 1 to 4 dx upon x, right? Correct. So okay, yeah, I made a mistake, that should be 2 minus integration dx upon 4x. Okay, 2 minus integration 1 to 4 dx upon x, right? Now if you solve this particular part, you're going to get the required area. Now if we solve this, then the required area will be like 13 upon 8 plus 20 upon 8 minus natural log of 4 base e, which will basically turn out to be 33 upon 8 minus natural log of 4. Okay, so that is the required area that we are going to have it with the as the area of this particular region, which is a very simple problem. If you look at the question over here, you can easily solve it. So, and therefore, the option number B is going to be the correct answer. It's a very simple, straightforward problem, right? I hope the solution is clear to all of you. Is the solution clear to all of you? Please let me know in the live chat. Is the solution clear to all of you? Is the solution clear to all of you? All right. Please let me know if you have any questions. Please let me know if you have any questions over here. So I hope this question is clear to all of you, right? I hope this solution is clear to all of you, right? So let's move to the next problem over here. Okay, so we have the next question, which is basically a problem from the inverse trigonometric function, right? And it's basically a question of inverse trigonometric equations, right? So if we look at the problem over here, and we have been given an angle theta, that theta is basically given as tan inverse of 2 times of tan of theta minus half of sine inverse of 6 times tan theta divided by 9 plus 9 plus tan square theta, right? So here the sine inverse or the inverse trigonometric function assumes its principal values, right? So that is what is mentioned, and it says that you have to find the total number of solutions that can be possible. Great. So now let's try to see how we will proceed with this solution over here. Now in order to proceed with the solution, let us try to assume, because we know the sine inverse of a function will return the angle value, right? So let us try to assume this following result, that is alpha is equals to half times of sine inverse of 6 times of tan theta divided by 9 plus 9 plus tan square theta, right? Let us try to assume that alpha as this over here. Then we can write theta as tan inverse of 2 times of tan theta minus alpha, right? Then we can write, then from here we can write, over here, that is theta plus, then from over here we can write theta plus alpha is equals to tan inverse of 2 times of tan theta, 2 times of tan theta. Now what I can do, since all these are for the principal values, so I can write this as tan of theta plus alpha is equals to 2 times of tan theta. And then if I expand this by using the compound angle formula, I can write this as tan theta plus tan alpha divided by 1 minus tan theta tan alpha is equals to 2 times of tan theta. Now from this particular result, 2 times of tan theta, we can, what I can do over here is that, now since I have assumed alpha is equal to half of this, what I'm going to do is that from here I can write 2 alpha, and if I take the sine of 2 alpha, then it is going to be like sine of 2 alpha is basically equals to 6 times of tan theta divided by 9 plus tan square theta, which is equals to 2 times of tan alpha divided by 1 plus tan square alpha, right? We have already know this by the formula, by the multiple angle formula, right? So we can write this over here as sine of 2 alpha as equals to 2 times of tan alpha divided by 1 plus tan square alpha, right? Now this will lead us to another equation that we will have it as 3 times of tan theta plus 3 times of tan theta tan square alpha, right, is equals to 9 times of tan alpha plus tan alpha tan square theta, right? I hope I'm doing it correct, right? Yes, correct. So please check the calculations again and again. Okay, in case you find out any mistakes in the calculations, you can point me in the live chat as well. Okay, so then we can take 3 as common, and we will take it as 3 times of tan theta minus 3 times of tan alpha, right? 3 times of tan alpha, which is equals to tan alpha into tan theta multiplied with tan theta minus 3 times of tan alpha, right? So I'm just taking the common and simplifying it. So therefore, this will simplify it us to a simple value, because this tan theta minus 3 tan alpha will get cancelled out, and we will have tan theta, we will have tan theta as 3 upon simply 3 upon tan alpha, right? 3 upon tan alpha, right? Therefore, now from this result, we can also do one thing. We can write tan theta. So, and if we take the another part of the solution also, then one part of the solution can also be tan theta is equal to 3 times of tan alpha as well, right? So let us take it and solve it step by step. Okay, so if I go with the first case, when tan theta is equals to 3 by tan alpha, let us consider this as the case 1 over here. So if I go with the first case from this particular solution, then I can go about and write tan theta plus tan of alpha, that I can write as tan theta by 3, and then if I solve this particular equation, over here, then I'm going to get it as, from here as tan theta is equals to 0, right? Tan theta is equal to 0, because we will have tan theta plus tan theta by 3 divided by 1 minus tan square theta by 3, which is equals to 2 times of tan theta, and if I solve it, we are going to get the result as tan theta is equal to 0, or we're going to have 2 by 3 is equals to 1 minus tan square theta by 3, which will give you the result as tan theta is equal to 1 or minus of 1, right? And if we solve this, we will have, three solutions, and tan theta is equal to 0, tan theta is equal to 1, and minus 1. So therefore the thetas for this particular range, minus pi by 2 to pi by 2, will have pi by 4 minus pi by 4, and then we will have 0. And similarly, if I use the second case, and if I solve it, right, and if I solve it, this will give me the result which will give me no solution. This will lead to another equation which will lead to no solution. Okay, so therefore you cannot consider this one, so you have to only consider this particular case over here. So therefore with this case, you are only going to have 3 solutions. So you are going to have only 3 solutions, and that means option number C is going to be the correct answer. Is this solution clear to all of you? Please let me know if the solution is clear or not. Okay. So I hope the solution is clear to all of you, right? So this was about the single correct option, and the option number C is going to be the correct answer. Okay. If you have any more questions, you can always put that up in the live chat. And in case you are watching this video after the live class is over, you can put your question in the comment section as well. Is this part clear to all of you? Right? So let's move to the next problem, right? Now let's move to the next problem, and if we look at the next problem over here, so this problem is basically from coordinate geometry, and we have to understand how we go about solving this problem, right? It's a very simple problem as well, again like the previous one. So if you look at the problem is set in a very simple manner, but by looking at the problem, it might look difficult in the beginning, but it's a very simple problem, trust me. So what I'm going to do is that, if for the second equation, if I take alpha as common, it is going to be like 4x plus 3y is equals to 12 upon alpha, right? And then it is said that alpha varies over the set of non-zero real numbers, and let t be the tangent and to the s passing through this point, and s is basically the locus of the point of intersection of this pair of straight lines, right? So s is basically a conics. Okay, s is basically any conics which is formed by the locus of point of intersection of this pair of straight lines, and then this t is a tangent to this conics s at point p comma 0 and 0 comma q for q greater than 0, and is parallel to the line, and is parallel to this particular line over here. So this information gives me the slope of the tangent is equals to slope of this line, which is basically nothing but minus of minus of x intercept by y, the coefficient of x by coefficient of y, which is basically going to be 4 root 2 4 root 2 upon 3, right, which is basically going to be 4 root 2 upon 3. So that's basically our equation of the tangent, right. Now let us try to first of all understand that what is our curve base. What is our curve base? Let us try to figure this first of all out. So from this result, if I try to understand that, if I try to solve this equation for x and y just by adding it, so this is the first equation and this is the second equation. If I just add first equation and second equation and try to eliminate, I will get, so from this also what I can do is that I can square it and then I can add it. So if I square it and then I add it, what I'm going to get over here is that, or you can also think of the simplest thing that I can think of right now is that if you just multiply the first equation and second equation, if you just multiply the first equation with the second equation, then you're going to get it as 16 times of x square minus 9 times of y square, which is basically equals to 144. So this is another way of writing a hyperbola. Okay, so that can be given as x square upon 9 minus y square upon 16 is equals to 1, which is basically a simple equation of an hyperbola, right? So it's an hyperbola. Okay, now we have to find out a tangent at 2 points. Okay, so for the given hyperbola, if we recall the equation of a tangent, so for the given hyperbola, if we recall the equation of tangent, which is basically a y is equal to mx plus or minus square root of a square m square minus b square, which is basically going to be 9m square minus of 16, right? So therefore, if I put it in place of m, I know the slope. The slope is basically 4 root 2 by 3, right? Correct? Yes. So from this particular part, I can write the given equation of the tangent, that will basically like 3y is equals to 4 root 2x plus or minus 12, 4 root 2x plus or minus 12, and that is going to give me, so if I pass it, so this tangent, sorry, this t passes through, p comma 0 and 0 comma q, right, and it says that q is greater than 0, right. So therefore, if I put that, and if it is passed to p comma 0, the p over here is going to be, so if I put y is equal to 0, p is going to be equal to simply as minus of 3 by root 2, and I will have q, if I put x equal to 0, then I will have q is equal to just 4. Okay, then I'm going to have q as just equal to 4. So therefore, my value of p into q is going to be minus 6 root 2, is just going to be equal to minus 6 root 2. With this, we are going to have the answer to this particular problem as option number A, as option number A. I hope this solution is clear to all of you. Please let me know if the solution is clear or not. Okay, so option number A is going to be the correct answer for this particular problem over here, right? So in this video, I'm not going to go much longer. Let's keep this video for only the single correct option, and in the upcoming videos, I'm going to show you the solutions for multiple type questions as well as the other integer types and other types of questions that has been asked in the paper 1, paper 2 as well, right? So with this, we will finish the J advanced paper solution. Okay, so I'm going to take one more session regarding the solutions, and then we're going to finish up all. Okay, so with this, I'm going to end and conclude this session over here. I hope you have enjoyed watching the solution as much as I did solving the solution with all of you. And with this, thank you.